Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 12.5, Problem 13. This is Section 12.5, Problem number 13. It says find the derivative of f of x equals the natural log of, there's a bracket, 2x minus 9 in parentheses, times also in parentheses x squared plus 7, close the brackets. So we're taking the log of some stuff, and the format is when our function is natural log of some stuff, then the derivative, f prime of x, is stuff prime over stuff. And that's what we can fill out. Now, the stuff happens to be a product, right? The 2x minus 9 in the first set of parentheses is the u, and the x squared plus 7 in the second set of parentheses is the v. So you could FOIL this out and clear the parentheses, and then you wouldn't need the product rule. And that's not a bad thing to do. But if you don't FOIL it, if you leave the product the way it is, you would have to do u prime v plus u v prime to do the derivative of the two sets of parentheses in our problem. So f prime of x is, we're going to do stuff prime over stuff. I'm giving myself plenty of room because to fill out that product rule, it'll take a bit of space. Let's do the stuff first in the bottom. That's easier. 2x minus 9 in parentheses times x squared plus 7. That's the stuff, no prime, in the denominator. So stuff prime on top, you start with u prime. So u is 2x minus 9. U prime is 2. Again, the 2x minus 9, the 2x gives me the 2 because x to the first power, the derivative is the number in front. The minus 9 has no x, so its derivative is 0. So that's my u prime, just 2. Then v, no prime, just v, so v is x squared plus 7. Then I have plus. Then u with no prime. So u with no prime is 2x minus 9. Then times v prime. So v is x squared plus 7. V prime is 2x to the first. So again, the x squared makes it 2x to the first. The exponent of 2 comes down times the number in front, which isn't written but understood to be 1. 2 times 1, there's a 2. X to 1 less power, second power drops to a first power. The 7 on the end, no x with it, so its derivative is 0. And that's the answer. And it can be simplified. You can clear your parentheses. Again, what would you have to do with it? You'd have to put in a number value for x, so you could do that now. But let me show you an alternate way to do this. And this is good. This is the answer. It's right. It's correct. But let's start with the original question. F of x equals the natural log. You have brackets with a couple of sets of parentheses in it. 2x minus 9 times the next set of parentheses, x squared plus 7. Close the parentheses. The whole thing's in brackets. Now, if you remember your properties of logs, the first property of log says if you have the log of a product, and this is a product, you can split it into two separate logs that are added together. So I could rewrite this, no prime yet. F of x is natural log of 2x minus 9 plus the natural log of the second piece, natural log of x squared plus 7. The first property of log says I can do that. That's legal. Instead of finding the derivative of one big piece, I could find the derivative of two separate pieces and add those answers together. So f prime of x equals, well, the first one, natural log of 2x minus 9. The 2x minus 9 goes in the denominator. Again, that's, I'm doing that as stuff. Stuff prime, which is 2, goes on the top. Again, the 2x gives me a derivative of 2. The minus 9 has no x. Its derivative is 0. So then I do plus the natural log of x squared plus 7. So the x squared plus 7 goes in the denominator. Again, that's the stuff in my stuff formula. And then stuff prime, 2x to the first power, the 7 goes away. And that's the answer in one line. It looks different from the answer we got up above using our product rule, but if you simplified this answer, it would come out exactly to the simpler version that we get right away. So if you don't remember the properties of logs, you get the answer no problem. It's a usable answer that you can put in any number value for x. But if you do remember the properties of logs, you get a nicer, simpler answer that's really the same, a little bit easier.